Gentlemen, welcome back to the shop. I offer up to you a steaming slice of hot, humble pie. A la mode, even. I done fucked up. Here's the thing. When you make a mistake, how you deal with it defines you as a person. You duck and cover, you try and sweep it under the rug, or do we look at it so we can learn from it? And I gotta say, thank you very much, because there's no way one man, me, one bumblefuck in a shop cannot compete with 800,000 brainiacs. Cannot happen. So this thing, I explained it as thoroughly as I could. I explained it completely wrong. That is because I didn't have what it actually does down. This is not a transducer what takes air pressure and converts it into a 4 to 20 milliamp signal. This is something from a bygone age. This is actually for pneumatic logic, and it's an interface device, sort of a stopgap measure to take 4 to 20 milliamp signaling, industrial automation signaling, and put it into old legacy air signaling systems, air logic. Now, first off, here we'll defer to sort of a patron saint of bumblefuckery, Richard Feynman. Dr. Richard Feynman was a very interesting cat. He was a professor. He was at the Manhattan Bomb Project, all sorts of stuff like that. A lot of stories about this guy, but I defer to the wisdom of his mother when she heard that he was going to be given an award from a now defunct magazine, that he was the smartest man alive. To which her response was, "Our Richie, the smartest man alive? God help us all." So there is no one, in keeping with the Feynman, there is no one easier to fool than yourself. I thought I had it figured out, but we're going to revisit it. And thank you very much to Terry, Michael, S.A., and on the YouTube, Mr. Torrenson, what yelled out, "You're wrong!" And also Yisbid360, also on the YouTube. Thank you very much for setting me straight. This Terry fella actually used these, and this Michael fella actually used these in nuclear facilities. They don't like to change things. Once something gets installated, they don't just change the instrumentation willy-nilly, so they are still using these things. And this is, as it says, a current to air converter. Serendipitously to this mea culpa self-flagellation, that practice makes perfect. That's what I tell the wife anyway. We get to see how this thing actually works, and it is pretty fucking cool because it is completely mechanical in its feedback loop. It's essentially a self-contained servo. Of course, an actuator. The difference between an actuator and a servo is that a servo is an actuator with built-in feedback. So this is a type of servo. It ends up being a type of servo. So starting at the beginning, we get 4 to 20 milliamps in, and according to the nameplate, we get 5 to 15 psi out, or 19 to 23 psi out. Essentially, we feed in 4 to 20 milliamps into this coil. This will have a north and a south pole. This magnet is very special. It's diametrically, the fuck is that? It's diametrically magnetized as opposed to axially magnetized, where this would be north and south. In this case, we have a north and a south right here. Now, this is held in place by a small flat spring, and it's off the main axis. So when we put current in here, it wants to align with this this central axis. And it is fighting against that spring force, wanting to bring it back to the zero position. Now, the more current we put in here, the closer it gets to the center point, to the center axis. As it gets closer to the center axis, what we have here is the air side. So there's air coming in here, and this is actually a nozzle, and then there's air coming in this bellows from the casement. So what happens is the air flowing out of here pushes on this guy, counteracting the force of, aiding the force of the spring and counteracting the force of the electromagnet. Now, here's the thing. As this pushes closer and closer, the pressure goes up. So that's the one control side. But the other control side is, as the pressure goes up, it goes into this bellows. Now the bellows expands and moves this away. So there's a fine balance there. Any kind of loading on here, when we use some of the air, there's a control feedback. If the thing is sitting away out here, you're going to get quite a bit less pressure than if the thing, you see that? Then if the platen here, that sort of reed, if it's really, really, really up close, the pressure is going to go up. So that means that we get more pressure out of the instrument. And that is how it works. The pixies go in. That's the problem, is I didn't know what it was supposed to do, and I assumed, which you always make an ass out of you and me, I assumed that it was just a pressure transducer. It's not. It's not. It's something completely foreign to me. I have never seen before, and very interesting. Thank you for edifying me, and I hope next time I'll catch it and have a closer look at what's going on. Maybe I could have got on the old gargler, did the jazz hands routine, but sort of ruined some of the fun. And that's the beauty of having a look at weird oddball shit in the shop. As a community, we can have some discourse and we fix our errors and figure out the best way to sort of do things. Thanks for watching. Keep your frickin' advice coming.